Kia ora, here's the last video going through last year's complex numbers paper. So in this video I've got 6 short achieved questions to go through. Question 1A is one where we're given 2 numbers in rectangular form and we just have to figure out what the product is and from that work out what the missing term is. So we just need to get on with it and multiply them together in rectangular form. So we've got WZ is equal to D plus 5I times 3 minus 4I. So that gives us 3D, I'll do the real part first, so 3D plus 20 plus 15I minus 4DI. And we know that that has to equal 38 minus 9I. So we can pick either the real part or the imaginary part here to figure out D. So 38 is equal to 3D plus 20. 3D is 18, giving us D is equal to 6. So that's that one done. In the next one, again, we've got rectangular form. We have to work out 26 over 2 plus 3i. So 26 over 2 plus 3i is one where we need to times by the conjugate. So 2 minus 3i over 2 minus 3i. That gives me, in the denominator, 4. These bits go. That's the whole point of multiplying by the conjugate, plus 9. And in the numerator, we get 52 minus 78i. So 52 over 13 is 4 and 78 over 13 is 6. So 4 minus 6i, and we have to draw that on the Argon diagram. So here's 4 minus 6i. There it is there. And we might just label that 26 over z. Okay, on to question 2. This time we've got one number in rectangular form, 2i, and one in polar form, and we want to find u divided by w. So it's really, really easy to do this when we're working in polar form. I'm going to take 2i and convert that to polar. So that will be 2 cis of pi on 2. So think about where that sits on the diagram. Here's 2i up here, and so the length is 2 and the argument is 90 degrees or pi on 2. That means that u over w is 2 cis of, which way around are we going? 2 cis pi on 2 divided by 2 cis 2 pi on 3. And when we divide numbers in polar form, we divide the moduli, so it's just going to be 1, and we subtract the arguments from each other. So it's cis of pi on 2 minus 2 pi on 3. I'm going to make those into fractions with the same denominator. So it's going to be divided by 6, and I'll have 3 pi minus 4 pi, giving me cis of negative pi on 6. Now I think it's fine to leave it like that in polar form, but we know that we can put that into nice exact form as well. So here's negative pi on 6. This length is 1, this length is 2, and this is root 3. So that's cos of negative pi on 6 plus I sine of pi on 6. So cos of negative pi on 6 is going to be root 3 on 2, and then it'll be minus 1/2 of I. So that is, if we'd been asked to put it back into rectangular, that's what we should have done there. So much nicer to use exact values. Okay, question 3. Complex number has got a modulus of 6, and we're told that that complex number is in the first quadrant. So let's see what that means, because that makes things really easy. Right, so if it's in here, because the argument's between 0 and pi on 2, that means that m has got to be positive. So the modulus of the complex number is 6, and the modulus of u will be 5 squared plus m squared. That gives us, squaring both sides, 36 is equal to 25 plus m squared. M squared is 11. So m could be either negative root or plus or minus root 11, but we know that m is greater than 0, so m has to be the square root of 11, not negative square root 11. And the last question here is one where we're working with surds. We have to rewrite this into this form. So 18 over 4 minus 2 root 3 times 4 plus 2 root 3 over 4 plus 2 root 3 is equal to 16. The whole reason to do this conjugate thing is to get rid of the middle annoying term, so these go, and then I'm going to have minus 4 times 3, right? So 2 root 3 times 2 root 3 will give me 4 times 3. In the numerator, we get 18 fours are 72 plus 36 root 3. Now, cleaning that up, I've got 72 plus 36 root 3, all divided by 4, 16 minus 12, which gives me 18 plus 9 root 3. Okay, so that's our final answer. There you go. I think that's all the achieved questions in the paper. So that's the end of the complex numbers paper for 2021. The ones for earlier years are videoed and on the external exams playlist.